In this tutorial, we're going to be continuing with our key concepts or key fundamentals in math. And the next key fundamental or the next basic thing that you ought to know is what is a factor really. Okay? Now, by definition, a factor is any number that can divide exactly into another number without leaving a remainder. Okay, so what really does that mean? Okay, so let's just look at some critical examples just to engage you and help you to understand the key concepts behind that. Okay, let's say I had 6 butterflies. Okay, so that's 1, 2, 3, 4, 5, 6. Okay, so I have 6 butterflies. Now, let's say you were asked, maybe by your teacher or a math coach, that you're asked a question, is 2 a factor of 6? Now, what you want to find, if I can get sets of 2's, there are 6 butterflies here. Now you want to know how many sets of 2's that you can get out of this 6 butterfly without any remainder or without any leftovers. Okay, so let's count with me. I have 1, 2, so I'm going to group these. So I am going to, oops, sorry, let me just get rid of that. Okay, good. Now we're going to group in sets of 2, so that's 1 set of 2's. Okay, good. And let me see if I have another 1, 2, that's 2 set of 2's. Okay, and I have another 1, 2. So basically I got 1, 2, 3 sets of 2's. Now if you notice, when I group them in sets of 2's, right, I got exactly 3 sets of 2's. So therefore we can conclude that 2 is a factor of 6, because 2 divided into 6 exactly without leaving a remainder. Now let's look at another example quickly just to reinforce what we're talking about. Good. Now let's say in this case I had 12 stars. Okay, now I have example number 2. Just let me make a note quickly. So this is, oops, let me get rid of that. This is example number 2. Example number 2. Now let's say we had some stars. Okay, and here I have 12 stars, my friends. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so here we have 12 stars. Okay, and you are asked to if 4 is a factor of 12. Okay, now if 4 is a factor of 12, then that simply means then 4 must divide exactly into 12 without leaving a remainder. Okay, and we could just divide our 12 sets of stars into groups of 4's. So let's let's try to see if it works. So I would have, this would be 1 set of 4. Okay, this would be another set of 4. Okay, and this would be another set of 4. Cool. So therefore we can conclude that since we got 3 sets of 4's and we didn't have any leftovers, then we can conclude that therefore 4 is a factor of 12. Okay, so that's what a factor means. It means that the number should divide exactly into another number without leaving a remainder. Now, since we know what is a factor, let's look at an example where a number is not a factor. Okay, so let me just quickly make a note here. Let's say I had here 7 oranges. 1, 2, 3, 4, 5, 6, 7. Okay, and a friend of mine asked me if 3 is a factor of 7. Okay, then let me try. I would have to divide my oranges into groups of 3s to see if I get how many. All groups should have 3 oranges in it. So let's divide. This would be, so I would have, this is one set of 3s. Okay, so that's 1, 2, 3. That's one set of 3s, and this would be another set of 3. Okay, but when you look here, I have 1 left over. Okay, so therefore, since when I divide 3 into 7, I have something left over, the something that I have left over is called our remainder. Okay, so I can say therefore 3 is, and this not, I'm going to write it in capital and underline it with red to say that 3 is not a factor of 7, because when 3 is divided into 7, it leaves a remainder. So 3 is not a factor of 7. Good. Thank you, and feel free to subscribe to this video to get our latest updates on our channel. Okay, bye bye.